Hello, good evening, everyone.
Good evening, ma'am.
Yeah, so this is your revision session for week 5 and week 6. Yeah, my screen is visible now.
Yes, ma'am.
Yes, ma'am.
Yeah, so in week 5, we will read about the permutation, combination, factorial, and how we select and arrange things. So all these things that are required for probability, we study in this week, right? So the very first topic that we study in this week is the basic principle of counting. Okay, so the very first topic is addition rule of counting. What is this rule? Anyone? Suppose we have an action A that can be done in n1 different ways, okay? And we have another action B that can be done in n2 different ways, okay? Now, the number of ways in which A or B can be done, that should be equal to what?
N1 plus N2.
And 1 plus N2.
Yeah. So A or B can be done in n1 plus n2 ways, right? So suppose we have 4 shirts and we have 3 pants. Okay, and we have to select either a shirt or a pant, right? So how many number of ways will be there to select either a shirt or a pant?
4 plus 7. 4
So
plus 3. 4 plus
yeah,
3.
so it will be 4 plus 3. So in 7 ways, we can select either a shirt or a pant, right? So this is your addition rule of counting. Now the next is multiplication rule of counting. And what is this? Multiplication rule. So
A
in
and
this,
B.
yeah, so we have action A, which can be done in n1 different ways, and B, that can be done in n2 different ways. Now we want A and B together. Okay, so that we can done in n1 multiplied by n2 different ways, right? Okay, so now suppose we have 4 shirts, okay, and we have 3 pants, and now we have to select one shirt and one pant. Okay, then how many number of ways will be there?
12.
Yeah, so it will be 4 multiplied by 3, which is equal to 12 ways, right? Is it clear? Now,
Yes,
suppose we
ma'am.
In
have,
OR condition, we will be using addition, and in AND condition, we will be using multiplication.
multiplication. Yeah, right. Okay.
What are the
So,
keywords can be seen in the question, ma'am? Like either or you told, for OR condition, what are the keywords we can observe and understand that it is addition? Normally, what and outcome can you please tell?
see, like for OR we use addition, and for AND condition we use multiplication. So you can understand like this. Like here, A and B are occurring together, right? Here we have to select one shirt and one pant, right? So both the things we have to select together. Okay, so that's why it will be 4 into 3. And here we have to select either a shirt or a pant. Okay, so we have to select only one thing at a time, right?
I
Okay.
want to ask one thing, ma'am. Like,
Sorry.
if we have to select one shirt and two pants, then also same way we will do.
See, we have four options for shirt, right?
Yeah.
And three for pants. So four
Yeah.
multiplied by three, because we have to select one shirt and one pant.
Okay.
Okay, here we have to select either one shirt or one pant. Okay,
No,
and
ma'am,
here
I'm
we have
asking
to
one
select
shirt and two pants. If we select, then
one
how?
shirt and two pants. Okay,
Yeah.
so that will be, yeah, that we will also study in combination. So we have to select one shirt. Okay, that will be 4C over, and we have to select two pants. So 3C2 it will be. Okay,
Okay. Okay. Got it.
yeah, so combination we will study further. Okay,
Okay. Okay. Understood.
so this is the multiplication and addition rule of counting. Okay, now let's take an example. So suppose you have to make a 6-digit alphanumeric password. Okay, and the password should have first two letters, followed by four numbers. Okay, now there are two conditions. The first is when the repetition is when repetition is allowed, and the second is when repetition is not allowed. Okay, so we have six places, six-digit alphanumeric password we have to make. Okay, okay, and for the first two we have to fill letters, right? Okay, and for the rest four it should be digits, numbers. Okay, so when the repetition is allowed, so we know that there are 26 letters in English language, right? So for the first place we have 26 options, right? And for the second place also we will be having 26 options, right? Because we can repeat the letters also, right? Is it clear?
Yes, ma'am.
Okay, and now for
But
the
ma'am, here it is not clear that we have to use only lower case letters or uppercase letters.
okay, just for this question, just use any case, suppose uppercase. Okay, like you have to use the letters. It doesn't matter they are uppercase or lowercase. Okay, if that is mentioned in the question, that will be different question. Okay, now for the last four places we have to fill numbers. Okay, so there we will be having 10 options, right? For this place also, and for third place and for fourth place also, right? Because we can repeat the number, right? Any doubt?
Yes, ma'am.
Okay, for the first one this will be your answer, and for the second one again you are having six places. Okay, so for the first place you are having 26 options, but for the second place we are left with only 25 letters, right? And for
Yes, ma'am.
for the last four places, so here we have 10 options, then we will be having 9 options, then 8, then 7, right? Because repetition is not allowed. Okay, so this
Yes,
will be your
ma'am.
answer, right? So the next thing is factorial.
In this case, if you are framing this question for addition rule, how it will be?
No, in this question we have to use multiplication rules, not addition.
Yeah, if you are can you change it into frame that in such a way that we can use addition rule?
Okay, suppose you are given, suppose you have to make a password, okay, and you are given two options or two methods to make your password, okay, method number A and method number B, in which you can make your password. So here the condition is something like you have to make 6-digit password, okay, and here suppose it is like you have to make 3-digit password, okay. So here, so some conditions will be given to you. So first we will calculate the number of ways for this in which we can make a password by using the process A, okay, plus number of ways in which we can use we can make the password by using the method B.
Okay, like in this, we have created repetition is allowed, not allowed. If it both, how many ways you can, we can add it, right?
No, what you are asking? Sorry.
What I'm asking is, in this, we have done in 2 ways now, when repetition is allowed and repetition is not allowed.
Yeah.
We need to find out the ways when both are required, then we can add this both ways, then we can come to the conclusion. Also will be applied there,
Okay,
right?
if it is asking for both, like if the repetition is allowed and repetition is not allowed, then
Yeah.
total, if it is asking, then we will add these two.
Yeah, that's right.
Okay.
Thank you.
Ma'am, in this session, will we discuss PYQ?
No, it's not PYQ session, it's just a revision session. Okay.
Okay.
Discuss all the topics for week 5 and 6. Okay. Yeah, so the next is factorial. Okay. So factorial is nothing but the product of first and positive integers. Okay. And it is called factorial n or n factorial. Right? And so n factorial is equal to n multiplied by n minus 1, then n minus 2, up to 3, 2, and 1, right? Is it clear? This is the formula for factorial, right?
Yes.
Okay. So suppose you are given 5 factorial. So it will be equal to 5 into 4 into 3 into 2 into 1, right? Suppose we are given 4 factorial. Then it will be 4 into 3 into 2 into 1, right?
Yes.
Okay. So now you can see that 4 factorial is 4, 3, 2, 1. Okay. So here you can see that it is the same, right? So we can write it as 5 into 4 factorial, right? We can write 5 factorial as 5 into 4 factorial, right? Is it correct? Okay.
Correct.
In general,
Yes, ma'am.
okay. So in general, we can write that n factorial is equal to n into n minus 1 factorial, right? For n objects.
Yes.
Okay. Similarly, 5 factorial, we can also write it as 5 into 4 into 3 factorial, right? Okay. So if you have to write it in general, so it will be, so if I is less than or equal to n, okay, so we can write n factorial as n into n minus 1 up to n minus I factorial, right? Okay. And the second last term will be n minus I minus 1, right? So we can write n factorial in this form also. Is it clear?
Yeah.
Yes, ma'am.
Okay. So now suppose you are given a question where you have to express you have to express 25 into 24 into 23 in terms of factorial. So how we can write it? So we can write like 25 into
25
24
factorial upon 2 factorial. No, no, no.
By
22 factorial.
So
25 divided by
you can
22
do
factorial.
so you can do manipulations according to you. Suppose I am here multiplying by 22 into 21 up to 3 into 2 into 1. Okay. And dividing by the same thing 22 into 21. Okay. Up to 3 into 2 into 1. Okay. So now in the numerator, I can write 25 factorial, right? And in the denominator, I can write 22 factorial, right?
Yes, ma'am.
Okay. Is it correct? So in this way, you can, if something calculation is given, then you can manipulate it. Like you can divide or multiply something. Okay, then we can change it into the form of factorial. Okay. Now the next topic is permutation. Okay. So what is permutation? Anyone?
When you choose and then
N
arrange
factorial by n
R
minus 2
items.
factorial.
Can you choose R items from N items and then arrange those R items?
Yeah. So we select our objects out of n, and then we arrange them also, right? That is permutation. Okay. So permutation is an ordered arrangement of all or some of n objects. Okay. So now suppose we have three different objects like A, B, and C. Okay. So how we can arrange them? All the three objects. So it can be A, B, or C, then A, C, B. Okay. Then B, A, C, then B, C, A, then C, A, B, and C, B, A, right? So in this way, we can arrange these three objects, right? Now suppose if we have to take only two things, two objects, right? So out of these three, we have to select only two, and then we have to arrange them also. Then what will be the possibilities? Suppose we have selected AB, so it will be AB or BA. Okay. Next, it could be BC or B, and AC and CA, right? So here we have selected all the three objects, and here we have selected only two objects out of three, right? Okay. Now, if we see the formula of uh, permutation, so NPR. So what is NPR? Which means that out of n objects, okay, n distinct objects, we are selecting R, and we are arranging them also. So it will be n factorial divided by n minus R factorial, right? This is the formula for permutation.
Yes, ma'am.
Okay. So in the first case, you can see that three objects are there, out of which we are selecting three objects, all the three. Okay. So according to the formula, it will be 3 factorial divided by 3 minus 3 factorial, right? So 3 factorial divided by 0 factorial. And we know 0 factorial is equal to 1, right? And 3 factorial is what? 3 into 2. So which is equal to 6. Okay, so here we can see that 6 possibilities are there, 6 number of ways in which we can arrange these three objects, right? Now, if we have to take only two out of these three, so it will be 3, 3, 2, right? So it will be 3 factorial divided by 3 minus 2 factorial. So 3 factorial divided by 1 factorial, and 1 factorial is again equal to 1. Okay, so again it will be equal to 6, right? Is it clear?
Yes, ma'am.
Okay. Yeah. And next we can see that NP0. So it is n factorial divided by n minus 0 factorial, right? So it is n factorial divided by n factorial is equal to 1, right? Similarly, if we have to select one object out of n, so it will be n factorial divided by n minus 1 factorial, which is n minus 1 factorial we can write. Okay. So it will be equal to 1. Sorry, n, right? Now, if we have to select all the three items, all the n items out of n, so it will be n factorial divided by n minus n factorial, right? So which is again equal to n factorial. Okay. So now here you can see that if we are given n objects, okay, and we have to arrange them. So there are n factorial ways to arrange n items, n distinct items, right?
Yes.
Okay. So n objects can be arranged n objects can be arranged in n factorial ways, right? Is it clear that how the formula came? Like we arranged n things in n factorial ways. So this comes from this permutation formula, right?
Yes,
Okay,
ma'am.
now let's take example. Okay, so the question is, from a committee of 8 persons, in how many ways can we choose a chairman and a vice chairman,
56.
assuming one person can hold only one position. Okay. So here what we are given that 8%, there is a committee of 8%, right? Okay, and we have to choose a chairman and a vice chairman. In how many ways we can do it?
56.
How 56?
8p2.
So it will be 8p2, right? So here we can see that order matters, right? Because if we are selecting two persons, suppose A and B. Okay, so suppose we are making A as chairman, and B as vice chairman. Okay, then it will be different if we are making B as chairman and A as vice chairman, right? So where we can see that we are arranging the items also. So we will be using permutation here. So we are selecting 2% out of 8, and then we have to arrange them also. Okay, so that's why we are using permutation here. So it will be 8p2, which is equal to 8 factorial divided by 8 minus 2 factorial. Okay, so which is 8 factorial divided by 6 factorial. So it will be 8 into 7, which is equal to 56, right? Okay. Now, if you're not using the formula of permutation, then simply you can see that we have to select 2% out of these 8. Okay. For the first person, you are having 8 options, right? Okay. And here we are given that one person can hold only one position, right? So for the second position, we are having only 7 options, right? So it will be 8 into 7. Is it clear?
Yes, ma'am.
Okay.
And suppose one person can take two positions, like
Yeah.
chair and vice chair.
Yeah, I'm coming to that point also. So
Okay.
suppose in this question, it is given that one person can hold only one position. Okay. So that's why it is for the first position, we are having 8 options. And for the second, we are having 7 options. Now, suppose it is given that one person can take more than one position. Okay. So for the first position, we are having 8 options, right? Then for the second position also, we are having 8 options. So it will be 8 into 8, which is 64. Okay. Okay.
Ma'am,
So
will
now
this
the
PDF, excuse me, ma'am, sorry to interrupt.
Mhm.
Will this PDF be available for us? This PDF.
Not sure about this, that whether it will be uploaded on the portal or not.
Okay, ma'am.
I have a question.
Yeah, sure.
How it is different from just selecting 2 people from 8 people, like 8C2.
See what happens in 8C2.
Mhm.
So combination and permutation. Okay, so we select always select different objects. But here we can see that the person is repeating. Okay, so 8C2. So in that formula, if you are using 8C2, so that 2 person will always be different. They can never be same. But here it is the condition is one person can hold uh, uh, more than one position, right? So we can repeat the objects. So that's why it will be 8 into 8. Okay, so one more formula for permutation here comes, that the number of permutations the number of possible permutations of R objects from a collection of n distinct objects. Okay, so here the word distinct matters. Okay, objects when repetition is allowed. Okay, so this is given by, so we can use the same analogy here also. So let's suppose you have to select R object out of the n. Okay, so you have R places suppose. Okay, so for the first place you have n options. For the second also you have n options. For the third also, and for the R place also you have n options. Okay, so that will be equal to n to the power r, right? Here you can see in the above question, n is equal to 8, right? Okay,
Yes.
and r is equal to 2. Okay, so when repetition is allowed, it is 8 to the power 2, okay, which is equal to n to the power r, right? Okay, so when we can repeat the things, okay, so it will be n to the power r. Is it clear now?
Yes, ma'am. It's clear now,
Yes,
but
ma'am.
I want to understand one thing, like the first part of this question. So when repetition is not allowed, uh, that is not in 8C2. That's not
Yeah, so
8C2.
yeah, it's not HC2 because okay, let me repeat this again. So whenever we study the permutation and combination, so that n objects are always distinct, right? And now if you have to select two
Yeah.
things, so that two things will always be different. Okay, so that will not be like you are selecting A 2 times. If you have 8 things, okay, that will not be selecting A 2 times. Okay, that's why, because here you can it is given that one person can hold 2 positions, so we can select person A for both the position also, right? So you
Yes.
just choose the common sense. So here we are having 8 options for the first place, and for the second place also you are having 8 options. Okay, so you don't have to use the formula of permutation and combination directly here. Okay, just try to study what question is asking. Okay. And based on that, we just use these concepts. Okay, it's not always we have to use the permutation and combination directly. Okay. Now the next thing is, so in the above formula, we studied that there are n distinct objects, right? But what if the objects are not distinct? Okay, so the next thing is the permutations when objects are not distinct. Okay, so what we can do? So the number of permutation of n objects when p of them are of one kind. Okay, and the rest are same. Sorry, rest are distinct. Rest are distinct. Okay, so your formula will be something like n factorial divided by p factorial. Okay, so suppose you have a word data. Okay, so here total we are having four objects, right? In total we have four. Okay, but we can see that two objects are same, right? So a is two times, it is repeating. Okay, so the number of ways in which we can arrange the letters of this word, it will be 4
4
factorial
factorial divided by 2 factorial.
divided by 2 factorial, right? Okay, so a is 2 times. Okay, that's why we have divided it by 2 factorial. Okay, now suppose we are having a word statistics. Okay, so here we can see that more than one object are of same type. So here we can see that there are 3s, okay, 3t and 2i. Okay, so similarly we can extend this formula. Okay, so the condition is that number of permutation of an object. Okay, when p1, I'm not writing the whole sentence. So when p1 is of one kind, okay, and p2 is of second kind, okay, and so on, pk of kth kind.
Then it would be n factorial divided by p1 factorial into p2 into pk factorial.
Okay, so in the formula, it will be n factorial divided by p1 factorial into p2 factorial up to pk factorial. Okay, now for this question, the number of ways will be, so total 10 letters are there in this word. So 10 factorial divided by 3 factorial.
Into 3 factorial into 2 factorial.
Yeah, into right? So this will be the total number of ways in which we can arrange the letters of this word statistics, right? Is
Yeah.
it clear?
Yeah.
Okay. Now the next is circular permutation.
Ma'am, if there is no repeatable word, then the denominator will be 1. You don't have to divide by any.
Yeah, you don't have to divide by anything.
Okay, okay.
Okay, so the letters are not repeating. Then all the objects will be distinct, right? So then we will use simply the above formulas which we have studied earlier. Okay, and we have already seen this thing that if we have n distinct objects, that we can arrange it n factorial ways, right? Okay, so if all the letters are different, okay, so then it will be n factorial, like the number of letters in that word, that factorial. Okay. Now the next topic is circular permutation. Okay, so in the above formula, we were arranging the things in arranging the objects in linear fashion. But what if we have to arrange the items in circular fashion? Okay. So suppose we have four objects A, B, C, and D. Okay. So these four distinct things we can arrange them like this: A, B, C, and D. A, B, C, and D. So here you can see that all these will be same, right? Do you agree with me that all these arrangements will be same? Because what we have done here, we have just rotated this thing. Suppose you have a bracelet or necklace, something like this of beads. Okay. So suppose this is your A, this is your B, this is your C, D, like this. So what we have done here, we have just rotated it. If you rotate this, then it will be something like this. That A is here, B is here, okay, C is here. But the necklace or the bracelet is still the same, right? So they both are same. We have just rotated this, right? So all these is a one arrangement we can say, right?
Yes.
Yes,
Any doubt
ma'am.
in this? Okay. So all these will be giving you same arrangements. There is only one arrangement. We have just rotated uh, the objects here. Okay. Now here one thing, that if clockwise and anti-clockwise are different. Okay. So in circular rotation, what we do, we just try to fix one object. Okay. So we have here we have four objects A, B, C, and D, right? So what we do, we just fix one item. Okay. And we try to arrange the remaining three. Okay. So here we have four. Okay. So we will fix one item and we will arrange these three. Okay. So we can make arrangements like this is A. So suppose I have fixed B here and I have put C here, then D here. Okay. Now next I can make like this. Okay. So I have fixed at this position. Okay. I will not change this. So this many arrangements will be there, right? Is it correct?
Yes.
Okay. So what we do in circular permutation, so total we have four objects, right? So what we are doing, we are fixing one thing, okay? And we are arranging the remaining three objects, okay? And we know that three objects or items can be arranged in three factorial ways, right? Is it correct?
Yes, ma'am.
Yes.
Yeah. And objects can be arranged in n factorial ways, okay?
Yes.
So here we are uh, fixing one object. So you can fix any of these, like you can fix B or C or D also, okay? And that will be 4 minus 1 factorial, which is 3 factorial, okay?
Ma'am,
Any doubt on this?
how clockwise and anti-clockwise are different? I can't
Okay.
understand the statement.
Yeah. See, so there are many situations where clockwise and anti-clockwise can be different, and clockwise and anti-clockwise can be same also. So here you can see that these two are the mirror image of each other, or we can say that this is just the anti-clockwise of each other. So here it is A. If you see the mirror image of it, so this is the mirror image of it, right?
Yes, ma'am.
B is here and then D is here. These two are also mirror image of each other, and these two also, right?
Yes, ma'am.
Okay. So here you can see that if you have to arrange n objects around a circular table, it will be n minus 1 factorial ways. Okay. But what if these clockwise and anti-clockwise are same? Then it will be n minus 1 factorial divided by 2, because what we are doing, we are considering these two as 1, right? So these two will be same. So we will divide by 2. Okay. So just suppose you have you can consider it like this. So you have a necklace or bracelet, something. Okay. Suppose this is your bracelet, you just flip it. Like suppose this is your A and this is your B. You have just flipped it. Okay. So B will come here and A will come here. Sorry, A will come here and B will come here. Okay, let me draw it clearly. Okay, suppose this is your B and this is your A. Okay, you have just flipped it. So this will be your B and this will be your A, suppose. Okay, but again, but you can see that in the both the cases, the necklace or the bracelet is same, right? So here clockwise and anti-clockwise will be same. But suppose if you have a circular table which you cannot flip. Okay, so suppose person A is sitting here, B is sitting here, C here, and D here. Okay, so if you're changing their position, that will be different arrangement, right? Okay, so there will be many possibilities where clockwise and anti-clockwise are same and they are not same. Okay, so both the possibilities are there. So if they both are same, then we divide by 2. Okay, if they are not same, then it will be n minus 1 factorial.
Okay,
Okay.
ma'am.
Okay, and you can understand the above formula n minus 1 factorial as this also. Suppose you have four objects that you can arrange in 4 factorial ways, right? Okay, and also you can, that one thing you can rotate and that will give you these 4 different possibilities. Okay, so suppose if you have 4 objects, I am taking n is equal to 4. Okay, so here you can see that it will be the same thing is given you 4 different possibilities also, but they all are same. So what we do, we divide by the 4 here. Okay, so if you divide 4 factorial by 4, that will be 3 factorial, right? Put it down. See what I'm saying here, that I have made these 6 circles. Okay, you can rotate this one also, right? If you rotate this, so this arrangement you can make like A here, B here, C here, and D here, right? So this will give you again 4 type, like 4 again, these 4, but these 4 are same because we are arranging the items in circular fashion, right? So this, now the second one, this one, okay? So we can place A here, then B here, then D here, and A here, okay? So in 4 types, we can arrange it. But they are giving us the same result, same arrangement, right? So what we are
Yes,
doing,
ma'am.
we are 4 factorial, then we will divide by 4, okay? So you can generalize it for n also, like we can arrange n things in n factorial ways, okay? And then they will be giving you n similar arrangements also, okay? Like you can see in the first picture, they all are same, right? So here I have written like A, B, C, and D. What if I have written A, C, D, and B? Okay, then also it will be giving you four similar things, right? So here it is 4. So that's why we are dividing by 4. If you have n objects, we will divide by n. Okay. So you can see that n factorial is nothing but n into n minus 1 factorial. Okay. Divided by n. Okay. So n will be cancelled out. It will be n minus 1 factorial. Right. So here the formula comes for circular permutation. Okay. So we can arrange n things around a circular shape in n minus 1 factorial ways. Is it clear now?
Yes, ma'am.
Okay. And this formula is there when clockwise and anti-clockwise are different. Okay. Okay. So when can you please mute yourselves? Okay. So here n minus 1 factorial when clockwise and anti-clockwise are different. But if these two are same, clockwise and anti-clockwise are same, then we will divide it by 2. Okay. So it will be n minus 1 factorial divided by 2 ways. Any doubt? Is this clear now?
So in the sum, it will be given that it will be anti-clockwise direction as well, because I don't remember solving any sum with the anti-clockwise given, ma'am. So generally, how the sum will be if it is anti-clockwise?
Sorry.
For the anti-clockwise sitting, the sum will contain that, is it? The people are sitting in the anti-clockwise direction, because I haven't solved any sum on the anti-clockwise thing. So just wondering how the sum will be if we need to use this n minus 1 factorial by 2.
Yeah, so in the beads example, I think there was one question regarding some necklace and beads. So here you can see that if you are given a necklace, like you have some number of beads, okay, that you have to arrange it circular fashion and you have to make a necklace, right? So there it won't matter that B comes here or here. Like here you can see that anti-clockwise and clockwise will be same.
Oh,
In
okay.
that situation, you will divide by 2.
Okay. Okay.
Right? Suppose this is your bracelet. You have just flipped it up. Right?
Yeah.
So that B will come here and A will come here. But again, the bracelet or the necklace is same. Because we are not changing the arrangement of these beads, right?
Okay.
These are same. Okay, so in that condition, we have to divide by 2.
Okay. Okay.
Okay.
And if the beads are of different colors,
So the beads are distinct. Beads are distinct.
still it
Here
would be
also.
n minus 1 factorial by 2.
Yeah, for
If
necklace, it will be n minus 1 factorial 2. Yeah, these are also distinct here also. They are not same. All are distinct.
okay, ma'am.
Okay.
And for if we are saying that we have 4 people and we have to arrange them in a circular, then still the formula we have to use n
Okay,
minus
so
1
yeah,
factorial.
see what if we are arranging them in circular table. Okay, suppose
Yes,
person
ma'am.
1 is sitting here, C here, A here, C here, but B is sitting here, D and D here. B in this in the second condition, B sitting here, D is sitting here. So these they both are different, right? So
Yes,
in
ma'am.
that situation, we will not divide by 2.
Okay.
We cannot
Okay, ma'am.
flip the table, right? So if you are sitting on the table, that will be different positions, right?
So we have to see the situation.
Yeah, you have to see the situation whether clockwise and anti-clockwise are same or they matter.
Okay, ma'am.
Okay, so that we will have to see in the question. Okay, so next thing is combination.
Ma'am, sorry to interrupt. Suppose if you need to solve the problems with identical items in the circular order, there is no way to do it, right? Like as all the beats of the
Yeah, then all the beats are same.
so in the case we cannot have a concrete answer.
So if all the beats are same, they are not distinct, then there will be only one way to arrange.
Yeah, one way to.
Yeah.
Okay, so in the exams, we won't be expecting those kind of questions.
No. In permutation combination, generally it is for distinct objects.
Oh,
If all are same thing, then like why would we arrange them?
yeah.
They all are
that's-
same. Okay.
Thank you.
Okay. So in combination, what is the formula for combination? Suppose we have n objects, out of which we have to select our object. Okay. And in combination, order does not matter, right? The
Yeah.
formula is n factorial divided by r factorial into n minus r factorial.
Yeah.
Okay. So in permutation, we select things, but also we have to arrange the things also. Like order matters there. Okay. Suppose we have n distinct objects. Suppose we have 8% again. Okay. We have to select 2%. Okay. And it does not matter like we just have to select two things. Okay. No matter we have selected A first or B first. Okay. So then we use combination. Okay. So NCR, the formula of NCR is n factorial divided by r factorial into n minus r factorial. We can write it like this also, n factorial divided by n minus r factorial into r factorial, right? So that will give us n minus r, right?
Problem statement will contain something like randomly, then we need to think about using this NCR formula, right, ma'am?
Yeah, we just have to select two things.
Okay.
Okay, order does not matter whether you have selected object 1 first or object 2 first. That does not matter. Okay, we'll see the question also.
Ma'am,
Okay,
one
so
doubt. In the
Hmm.
circular permutation, what if the repetition is allowed? If we can arrange A in 4 place or B in 4 place or 2 A's, 2 B's like that.
Then we will not use this formula. Then according to the situation, we will have to see how we can arrange. But generally, we do not see questions like that. Suppose we have 4 things
Yeah.
and you can repeat also, but then simply I can say that we will not use the fixed formula. We will have to see according to the situation, like what situation is given to us. According to that, we will select the things and we'll see how we can arrange it. Like we have to do that question in parts.
Can
Because
you
repetition
give
is
me any
allowed.
example if possible, no?
Right now, I don't have any question on that, but
Okay.
yeah, I can tell you the approach. Okay.
Okay, ma'am. Thanks.
So here you can see that in this statement, NCR is equal to NCN minus R. Okay. So what we can conclude from this statement or from this equation is that selection of R objects out of the N is equal to the selection of N minus R objects out of N, right? What is this? Selection of R objects out of N distinct objects, right? And what is this? This is nothing but the selection of N minus R objects, right? Out of N objects. Okay, so they both will be same, right? Yes or no?
Yes,
You
ma'am.
can see in the formula also. Okay, now let's see your question. Okay, so uh, suppose we have a question paper, okay, which contains 12 questions, okay, in total, and which is divided into two parts. Okay, the first part contains 7 questions, okay, and the second part contains 5 questions, right? And the condition is the student has to attempt 8 questions in all, okay, and selecting at least 3 questions from each part. Now tell me how we can do this question, how we can attempt the question paper. Okay, so again, repeating the question. Total we have 12 questions, right? First part contains 7 questions and second part contains 5 questions. Total the student have to attempt 8 questions, okay? But the condition is at least 3 questions they have to attempt from each part. Okay, then how will you solve this question? What will be the different possibilities?
By making cases, first of all.
Yeah, what will be the different cases here?
Yeah, it would be 7C3 into 5C5 one case.
Well, first we need to find out, like, for the 8 questions, he can choose 4,4. That's the first combination. So like that, we have to find all the combination and then find the apply the
Sum of all the cases.
Yeah. So what we have to do? Condition is that they have to attempt at least 3 questions from each part. Okay. So now suppose the students select 3 questions from part 1. Okay. So the remaining 5 they will select from the second part. Okay. Next condition. Yeah. Next will be 4 questions from part 1 and 4 questions from part 2. Next could be 5 questions from this and 3 questions from this, right? So these will be the 3 cases here. Okay.
Yes.
Any other case which is possible?
No, ma'am.
No, right? Because we have to attempt at least 3 questions from each.
Yeah.
Okay. And in total, we have to attempt 8. Okay. So these possibilities will be there. Okay. So either the student can select this option or this or this. Okay. 3 different ways are there, right? Okay. And out of these 3, only one like in one way the question paper can be attempted in one time, right? So what we have to do, like out of 7 we have to select 3, and out of 5 we have to select 5, then we will add it, right? So this is your one possibility, this is your another. Okay, now I will explain why we are multiplying here and adding here also. So now the next case is 7C4. Out of 7 the student is selecting 4, so 7C4 and 5C4, right? Then we will add them, then it will be 7C5 into 5C3, right? Okay.
Yeah.
Okay. So here what we can do, why I have multiplied here, I have used multiplication rule, because they both are occurring together, right? We have to select 3 questions and 5 questions from the second part, right? That's why we are multiplying here and we are adding these 3. This is one possibility. This is one possibility and this is another possibility. Out of these 3, at one time only one can be selected, right? Either the student will be selecting 3 questions from first part and 5 questions from second part, or he will be selecting 4 from the first part, 4 from the second, or he will be selecting 5 from first and 3 questions from the second part, right? So that's why we will be adding these possibilities. Any doubt in this?
No, ma'am.
So like when we use addition rule and when we use multiplication rule. Is it clear now?
Yeah.
Okay.
Yes,
Ma'am,
ma'am.
I have a question.
Hmm.
I understand this part, but
Mhm.
suppose the question is like the student has to attempt at least 8 questions. In that case, the student can attempt 8 or 9 or 10 or 11 or 12 questions.
Okay,
So
then
in
we will
that case,
have to make,
same.
yeah, then we will have to make more cases, more number of cases will be there.
Okay, but the attempting each case going to be similar. So in that case, suppose 9 in the sense 8C3 into 5C5, something like that, we have to add more cases. But the approach is going to be same. Is it correct?
Yeah, in that case also, we will have to see how many the different cases we can make
Okay.
according to the condition which are given in the question.
But this approach is going to be same, right?
Yeah, the
Selection
approach is
of
going to be same, yeah, but we will have to see the question also.
okay.
It
Okay,
can
according,
be at least, at most, and all questions, right?
yeah, all the different kind of questions can be given to you, like at least 3 questions, maximum 2 questions. According, you will have to see that how many total number of questions are there, okay, and how many possibilities you can make.
Okay.
Okay, so you will have to make the cases, different cases you will have to make, and accordingly you will have to use the formula of combination. Okay, and then you will add different possibilities. Okay, so that depends on the question, what is given in the question. Okay, so there is no hard and fast rule that can be applied to all the questions. You will have to see the situation, right? Any doubt in this question? Is it clear now?
Yes.
Okay. Now suppose the question is given endpoints. On a circle, how many lines can be drawn? So what will be the answer? How will you solve it?
NC2.
Yeah. So suppose this circle, okay, and there are endpoints on it, okay. So for making a line, we need 2 points, right? If you have to make if you have to make a line, we require 2 points, right? But now it depends that whether AB or BA are same or not. Okay, so generally, if you're asked to make a line segment, then AB and BA are same, right? But what if the direction is also there? Suppose AB is a vector. Okay, so in that case, vector AB and vector BA will be different, right? Okay, so if you are asked to make only lines, so then order will not matter. Then AB and BA will be same. Okay, line AB and line BA are same. In that case, we will be using combination. But if the question says that AB is different from BA, like there is direction also, like going from point A to B is different from going from point B to A, right? So in that case, order will matter. So in that case, we will be using permutation. Okay, then it will be NP two ways. If order does not matter, then it will be NC two ways, right? Is it clear? So generally, if the question is this only, like how many lines can be drawn, answer will be NC2 only. Okay, but what if this case is also given? Like I have just given you another case also. Okay, so if the direction is also matter, okay, then it will be NP2. Then we will use permutation. Is it clear now?
Yeah.
Can you explain with an example, please?
Suppose you are you have you are going from Chennai to Delhi. Okay, or you are going from Delhi to Chennai. These two are different, right? This is your point
Yes.
A, this is your point B, this is your point B, and this is your point A. Okay. In that case, these 2 points going from A to B will be different from going from B to A, right?
Understood. My question is like how it is different from 2 times NC2.
2 times NC2, what?
Yeah, okay. So assuming that we are having all the directed lines for any 2 points A and B, we are making the line by connecting A to B and B to A. Both are kind of different. Now it is 2 times of NC2, right? Like, or how it is different from 2 times of NC2 is the question.
So you are
The
saying
point is
you are saying this
why
thing as
we had to think about the order, because the order is
no.
I'm unable
See
to
what
understand
I'm
the order you are mentioning about the order. For me, it looks like A and B are selected. From there, we can make
yeah,
the directed
I have
lines.
yeah, for this particular question, for this statement, answer is NC2 only, right?
Yes.
For this particular question, answer is NC2, no doubt.
Yes.
Okay.
Yeah.
But I'm just giving you a situation. Like in the other question, if it is mentioned that going from like I think if you have solved the activity questions, there will be some questions like going from this station to this station, from going to Chennai to Delhi, going from Delhi to Madras, like Delhi to Lucknow or something. In that case, point A going from point A to B is different from going from point B to A.
Okay. Yeah.
Okay,
Understand.
where the direction matters. In this question, it will be NC2 only because this is line. If you call it line A, B, or BA, that does not matter here. Okay, that will be same. But just in case if the direction also given, then order will change, right? Then the
Yes.
order will matter here in that case.
Yes.
Okay. Like if you have a ticket from station 1 to station 2, okay, but if you have to travel from 2 to 1, then you will have to take a different ticket. You can understand it like this also.
Yes. Yeah. For that
Okay.
matter, actually, 2 NC2 is equal to NP2 also. So that way also it is same. Yeah, that makes sense.
Okay. Yes. So when order matters, you will have to use permutation. Okay. So this is a point. Like I want to make you understand where we have to make use of permutation and where we have to use combination. Okay. So
Yes.
by seeing the question, you will have to decide whether order matters here or not. Okay.
Thank you.
Okay. Now let's see another example. Suppose you are having a 100-meter race. Okay. And 8 athletes participate in this race. Okay. So the first question is how many number of ways to award gold, silver, and bronze. Okay. And the next is just to select top 3 athletes. Okay. We just have to choose top 3. Now, what will be the answer?
In first one, it would be 8P3 and second one, it would be 8C3.
Yeah. So in the first one, we know that order will matter here. Okay. Suppose out of 8, we have selected 3. Okay. 3%, A, B, and C. Suppose A come first, B second, and C third. Okay. We have selected 3%, but if A come first, B second, C third, and what if A comes second, 2 first, and C third? That will be different, right? So order will matter here. So in the first case, we have to use permutation. And here we just have to select top 3. Okay. no matter A comes first or something, like we are not giving them the positions, we are just selecting three out of 8, right? So it will be 8, C, 3, right? Any doubt in this? You can understand it like this also. Suppose you have a class of 40 students. Okay. First is you have to select or choose 2 leaders. And the next is you have to choose the person for captain, for the position of captain. Okay. And for the position of vice captain. Okay. This is also a similar kind of question. Now, what will be the answer?
First is 8C2 and second is 8P2.
Yeah, so
Sorry,
first is 8.
40C2 and sorry, 40C2, 40P2.
Yeah, sorry, 40, not 8. So first one is 40C2. Okay, out of 40, we just have to select 2 leaders. Okay, here we are giving them a position of captain and vice captain. Okay, suppose we have selected 2 person A and B. Okay, so A is captain, B is vice captain is different from B is captain and A is vice captain. Okay, so here we will be using permutation. It will be 40P2, right? Okay, so these were the topics in your week 5 and week 6. If you have any doubt, then you can ask. Any question, any doubt? Hello.
No, ma'am.
No doubt.
Ma'am, I have doubt in the grade assignment of week 5.
Ma'am, I have one topic, ma'am.
Which topic? Yeah, yeah.
Ma'am, can you please explain one more time circular permutation?
Okay. Yeah, what you want to ask?
Ma'am, actually, I tried to understand, but I couldn't understand. Can you please explain one more time?
Okay. So what we do in circular permutation, suppose we have 4 different things. Okay, A, B, and A, B, C, and D. Okay. So first of all, you can arrange A, B, C, D. Like A, next to A, B, next to B, it is C, next to C, it is D, then next to D, it is E. Okay. And if you try to see all these 4 figures, okay, you will see that this is nothing but the same. Here I have written A at this position, then B, C, and D. Here I have started A from here, then going from B, C, and D. Okay, then in this, I have started from this position, A, then B, then C, and then D, right? And here I have started from this position, A, then B, then C, and then D, right? So you can see all these 4 are same.
Yes, ma'am.
Because, okay, so because we are arranging them in a circular fashion, so all these 4 will be same. Okay. Now,
So, okay.
yeah, okay. So now the first thing is here 2 things are there. Anti-clockwise and clockwise are same and they are different. Okay. So if they are different, okay, so what we do to arrange n objects in circular fashion, we just try to fix one thing. Okay, what we have done, we have fixed A at this position, right? So A is at this position in all these 6 figures, right? Then what we have done, we have arranged the remaining 3 objects, which is B, C, and D here. We have arranged these 3 in different possible ways. Okay. Now, if you are thinking that there can be more possibilities, then what they will be? They will be the rotation of all these figures, right? So here, like this is ABCD. This is same as this, right?
Yes, ma'am.
Okay, 1 minute. So you can see this figure is same as this, right? And
Yes,
this
ma'am.
figure is same as these, right?
Yes, ma'am.
Okay. Similarly, you can do with this one also. You can rotate this one also. Okay. If you rotate this one, like here you have started A from here. Next, you can do A here, then B here, then D at this position.
And this is
Okay.
for clockwise.
No, this is not clockwise, anti-clockwise. This what I'm doing, just rotating this thing.
Oh, okay.
Okay. Just try to understand these four figures are same. Do you agree with this point or not?
Yes, ma'am.
Okay.
Yes, ma'am.
If you try to make different arrangements for these four, these will be these six figures only. Okay, if you're thinking that there will be more possibilities, that will be the rotation of these figures. Okay, the figure could be a little bit messy. Okay.
Okay, ma'am.
So what we do, we just fix one point, one object, and we try to arrange the remaining objects. Okay, so you can rotate this figure also, then it will be like here I have written A at this position. What if I write A here, then B here, then D here, then C here? Okay, this will be same, right?
Yes, ma'am.
Okay, so you can rotate in other fashions also, like A here, A, then B here, then D here, then C here. Okay, so that will be the rotation of the same figure, right? Okay, so they are not different, they are same. They are just the rotation of all these six figures. Okay, but if you try to find the different arrangements, so they will be these six figures only for these four objects.
Okay.
Okay, so that's why what we have done, like for you arrange n on objects in n factorial ways, right? Okay, and what we have done, these four are same. Okay, so that's why we divide by 4. Okay, here it was 4, so 4 factorial divided by 4. Okay, if you have n objects, okay, then it will be giving you the same n things, like same n arrangements that we have rotated. Just try to understand what I'm saying.
Yes, ma'am. Now got
I
it.
cannot make. Okay, so that will be n factorial by n.
Yes, ma'am.
Okay, so that's why it is like n minus 1
When
factorial.
it is same, then it will be n minus 1 factorial.
Yeah, it will be n minus 1 factorial. Okay.
Yes, ma'am.
And
Got
this
it.
is when clockwise and anti-clockwise are different. Okay, what is clockwise and anti-clockwise? You can assume it as the mirror image of this. Okay, so you can see that these two figures are the mirror image of each other, right?
Yes, ma'am.
Okay, so if these two are different, then it will be n minus 1 factorial. Okay, but if what if you are considering these two as same? Okay, as I told you in this bracelet example. Okay, so then we have to divide by 2, because we are considering that these two are same. So these two will become one arrangement only. Okay.
Okay, ma'am. Got it.
Okay. Yeah. Any other doubt?
No, ma'am.
Yeah. Anyone else? Yeah. Any other question, or we can end the session if you don't have any question.
Actually, I have a question, but it is not related to the topic.
Okay, so
Can
from
I,
where you have to ask question?
ma'am, it is regarding quiz 2. Actually, 3 days ago, I got diagnosed with dengue, and I don't think I can make it to quiz 2. I will be appearing for quiz 2.
You will be appearing for Quiz 2 or not?
No, ma'am, I will not be.
Okay.
Okay, ma'am. So
Um,
I
did you
wanted to ask.
mail or something
No,
informed
ma'am.
the team?
No, ma'am. No, ma'am.
Eligibility to take NTERM is you should be present in one of the two quizzes, like quiz 1 or quiz 2, and your graded assignment score should be greater than the 40%.
Yeah,
That's
yeah. I think I'm passing those criteria.
Okay, then
then
it's fine.
okay.
Ma'am,
But
so will my CGPA go down by
yes,
this?
yes. It will affect your marks.
Yeah.
Like how? I don't know, ma'am. How much marks or how will it affect my CGPA?
30%.
Yeah. Okay, ma'am.
Okay. Any other doubts?
Ma'am, there is a question where we have to find the word in dictionary and return the number uh, at which that word come in the dictionary. Can you please
Uh,
explain that question?
yeah, what is that question?
If all the permutation of word graph are arranged in dictionary order, then what will be the 73rd word?
You have to arrange this word dictionary order, right?
Yes, ma'am.
So what will be the 73rd word? This is your question.
Yes, what will be the 73rd word?
Okay. So according to the dictionary, if you arrange, then like it will be starting from A. Okay, and then accordingly we will have to see.
90% போட்டுச்சுடா
90% scholarship.
Will you please mute your mic?
Yeah, Ravi Kumar Dayalan, could you please mute?
Yeah, so in this way we have to arrange, but we have to find a particular word, 73rd. Okay, I will solve this question, then I will tell you.
Okay, ma'am.
Yeah, any other question?
நீ தட்சிணா அம்மா கூப்பிடுறாங்க பாரு
Else we can end the session.
என்னாச்சுன்னா நான் ஒரே கையை வாஷ் பண்ணேன் இது அதை கொட்டி நீ உடனே வா கீழே வச்சிட போறாங்க
Ma'am, I have doubt in the week 8 practice assignment question number 9.
Week 8. Hello.
Yes, ma'am, week 8 practice assignment question
Okay.
number 9.
In this session, we will be discussing week 5 and 6. Okay, that there will be a separate session for that also. There we can discuss week 8 question.
In week 6, I have doubt in graded assignment question 5th and
Okay. Can you please check the solution, which is already given to you? Hello.
Yes, ma'am, but ma'am, I'm not able to understand. Can you please explain?
You saw that solution, right?
Yes, ma'am.
Okay, I will explain by that solution. Um, graded assignment 6.
Yes, ma'am.
Okay, 1 minute. Yeah, which question?
Ma'am, question number 6.
Question number 6. Yeah, this is your question. Find the total number of ways to form a m-digit number without repetition from the digit 0 to n, right?
Ma'am, it is not my question. My question is how many 21-digit number can be formed such that they read the same way from either of the side?
Okay, so I think fifth question. Fifth one, right? See on the screen.
Yes, ma'am.
Okay, so the value of n is given in your question.
Yes, ma'am. It is 5-digit number.
5-digit number. The question is how many 5-digit number?
Ma'am, 5-digit number not. It is 21-digit number.
Okay, it is 21-digit number can be formed such that they read the same way, either from either of the side. Okay. So did you check the solution? So what we do in the palindrome, it is like okay, so you have 21 digit. Okay. Suppose this is your 10 digit. Okay, just suppose this is 10. Okay. This is 11. Then again 10. Okay. So that will be total 21, right?
Yes, ma'am.
So what we have to do? We have to arrange things here till this point, and then we will put the same things here, right?
Yes, ma'am.
Okay, so we have to find the arrangement for these places, and then they will be auto-filled. Okay, so in the solution you can see. Okay, so for the first place you are having for an n-digit number to read the same way for either side, the first, second, third, and up to n minus 1 divided by 2th place you have to digits needs to be the same as nth, n minus 1, 1th, and up to these. Okay, so now in this question, number of ways to fill the 9. So we have total 10 digits, right?
Yes, ma'am.
Okay, so okay, 1 minute. So for the first place, we will be having only 9 options because we cannot fill 0, right? Because we have to make 21 digit number, right? Okay.
Yes, ma'am.
So for the first place, we will be having 9 options, right? Then for the second place, we will be having 10 options.
Yes, ma'am.
Okay. Then for the next also we'll be having 10 options, right?
Yes, ma'am.
Okay. For this place, we will be having 9 options. For this place, we will be having 10 options. For this also, and for up to the 11th place. Okay. So it will be 9 into 10 to the power, like for up to the 11th place. Okay, so in this question, it will be, it is n minus 1 by 2, right? So what is n? N is 21. Okay, so it will be 21 minus 1 divided by 2. Okay, which is 9 into 10 to the power 10, right? Because these are 10 places from second place to 11th place.
Yes, ma'am.
Okay, rest will be same. Okay, so it will be only one way to, like here you have filled suppose A, here also it will be A. Okay, we have to fill digits, not letters. Suppose you have filled 3, 7, 8 here, so it will be 3, 7, 8 in this fashion, right? So we have to make arrangement for these places that will be same. Okay, so for the first place we will be having 9 options because we have to make 21 digit numbers, so we cannot fill 0 here. Okay, for the rest of the places we will be having 10 options for each place. Okay, so 10 to the power 11, 10 to the power 10 it will be, right, from second place to 11th place.
Yes, ma'am.
Okay, so it will be 9 into 10 to the power 10.
Yes, ma'am. Ma'am, and I find difficulty in doing the option questions in which we have to given like this. You have 4 option for each question. Then how many ways to select it? In these types of questions, I find difficulties.
Instead of number, if it's a word, how it will be? It will be 10 into 10 raised to n minus 1 by 2.
Sorry?
If it is a word instead of number, 0, we cannot use the initial number as 0, right? But for word, we can use all the alphabets in the
Yeah, we can use all the alphabets.
So it will be 10 into 10 raised to n minus 1 by 2.
Then it will be 10 to the, so this 9 will be 10 again. Like the number of, like if we are having 26 letters, so it will be 26, 26, 26.
Okay.
Okay, or whatever the letter is given to you in the question. Okay. Yeah, so what you were asking, number of questions, some, like repeat the question.
I'm asking that I find difficulty in doing the question like this, in which we have given that for each question you have 4 options, and in how many ways you can choose the options or choose the answer the questions.
So in that, like that also depends what is the exact question. So we have to see this thing also, that either you can select any option or you cannot select any option. Like you can leave the question also. So it depends on the question, like if the question is MCQ or MSQ type.
Ma'am, when it is
All the
then how we can do this?
suppose if it is MCQ, okay, so you have to select only one option, or you can leave the question also. Okay, so you're having, for one question you're having 4 options, but you can leave the question also, so that is also one way, so total 5 ways will be there, right, for one question only, I'm saying. Okay, so accordingly you will have to see like how many total number of questions are there. Okay, and if it is a multiple select question, okay, then there are possibilities, like either you are selecting only one question, one option. Okay, that one option can be any out of these 4, right? Now the second possibility is you are selecting 2 options, right? You are having A, B, C, D 4 options, and you are selecting any 2 options, right? So that will be 4C2 ways, right?
Yes, ma'am.
Okay. Now next possibility is you are selecting 3 options. So out of the 4 questions, you have to select 3 options. So it will be 4C3, right? And the next is all the 4. So it will be one way only, 4C4, right? Or if the if the question is not compulsory, you can leave the question also. So that is also one way. Okay. So in this way we see. Okay, now that depends on the question. What is your exact question? How many number of ways are there? Question is compulsory or not? So all the things, all the situations, conditions you have to consider, and then you will decide. Okay. But this is the approach to solve the question. Okay, is it clear now?
Yes, ma'am, it is clear now.
Yeah, any other question? If you don't have any question, then we may end the session. Okay. Okay, no doubt.
Now, I have a question from PYQ.
Okay, what is the question?
The question says that administration of a university has started to create roll number for the students.
Okay.
And the format is 23Z170. And using the digits 0, 1, 2, 3, 4, and 5, 6. Add a capital letter at the third position, as the mentioned, like 23Z170. So they are saying that no digits are repeated. Find the number of ways in which the administration section can create a unique roll number. The format is
1 minute.
23Z170.
Yeah. What is the format? 21.
23. 21, 23. Same, both are same. Z.
21 Z.
170.
170.
They say that the question says that the third digit should be a capital letter. Means third entry should be a capital letter. And the digits which they are using is 0, 1, 2, 3, 4, 5, 6.
0.
1, 2, 3, 4, 5, 6.
1, 2, 3, 4, 5, 6. Okay. So these digits we have
And
to use.
no repetition allowed.
Okay, no repetition.
Allowed.
Okay. And how many digits we have to use for the roll number?
These 3 and 3, 6, 5 digit and 1 capital letter.
No. Like we can use these digits in our roll number, right?
Yes, ma'am.
Okay. And how many digits are there in your roll number?
Digits are 2, 3, 5. 5 digits.
No. Repeat the question again.
Administration section of a university has started to create a roll number for the students. Following the format given, this format 21/7, using the digits 0, 1, 2, 3, 4, 5, and 6, and a capital letter at the third position. As you know, digits are repeated, then find the number of ways in which the administration section can create a unique roll number. Means the
Okay, so this
digits.
is the format given to us.
Yes, yes.
So these four, 6 places are there.
Yes.
Okay,
One place is
and
for a capital letter.
okay, so this is just one roll number given to us as a sample, right?
Yes, ma'am.
Okay, so at the third place, we have to fill capital letter, right?
Yes, ma'am. Yes, ma'am.
Okay, so 26 options will be there to fill this position,
Yes.
right? And we have to use these digits only.
2, 4, 7. Yes, ma'am.
Okay, and repetition is not allowed.
Yes.
So these are 7 digits, right? 7 numbers.
Yes.
Okay.
So
Repetition. Okay, repetition is not allowed.
Yes, ma'am.
Okay, and anything mentioned that we can use a zero here or not?
No, I think we cannot use zero in the first place.
Or something given that we have to make 6-digit password rule number something.
It is not mentioned in the. Ma'am, I think we can use zero because it is not
use
like
zero.
a. Yes, yes, we can
Yeah.
use zero.
Okay, so here for this place we will be having 7 options. Repetition is not allowed.
Yes.
So then 6, then
Six.
5, then 4, then 3. Right?
Yes, ma'am. Actually, I was thinking that can we use zero or not? Now I think we have find that it is a categorical variable, so I think.
Yeah, you can use 0 here. So because we are not something like we have to make 5-digit number or 6-digit number.
Yes, ma'am.
So we cannot use 0. Here we can use. Okay.
Thank you, ma'am.
Oh, thank you.
Thank you. It was a straightforward question.
Okay. Now should I end the session?
Yes, sir.
Yeah, okay. Thank you, everyone.
Thank you.
Thank you, ma'am.